Next, we are going to start loss of energy during redistribution of charge. See, as we know, when we connect two bodies containing some charges Q1 and Q2 with each other, there occurs a transfer of charge from one body to another body. Now, during this process of movement of charge from one body to another body, there occurs some loss of energy in the process. Now, we will be calculating that energy, the lost energy during the process of distribution of charges from one body to another body. Now, let us suppose the two bodies are carrying charges Q1 and Q2. They have separate capacities of C1 and C2. Now, the bodies, when they are connected through a connecting wire, the movement of charge will continue until they attain a common potential. So let us write the expression for the initial energies of both these bodies. So initial now the initial energy would be equal to, we can denote it by ui, it will be equals to energy possessed by first body plus energy possessed by second body. So this is initial energy of two bodies. Now when they are connected together, they will attain some final energy, and this final energy will be equals to 1 by 2 into square of total charge when these two bodies are connected together over total capacitance C1 plus C2. So this is the final energy. Now to calculate the loss of energy, we can donate loss of energy with delta U, that will be equals to initial energy minus final energy. Now we just need to subtract the above two equations. We just need to subtract 2 from 1, and by using simple algebraic method we can subtract these two values, and after subtracting these I will be writing the final result. You do the required calculations in your notebooks. So after subtracting these two values, you must reach to a expression C1 C2 over 2 C1 plus C2 V1 square plus V2 square minus 2 V1 V2. Further, this expression can be simplified and can be written as V1 minus V2 square. So you will reach this expression, and this is the final expression for loss of energy during redistribution of charge. You must remember this final expression. So from this expression it is clear that V1 minus V2 whole square can never be negative. It will always be positive because you have square of this value V1 minus V2, and of course product of two capacitances will always be positive. So this result is a positive answer. So this shows that initial kinetic energy minus final kinetic energy is something positive. That means there occurs some loss. So we can also write a special case here. If we consider V1 equals to V2, now in this case V1 minus V2 whole square will become 0. Now if this becomes 0, then your loss of energy will also become 0. Loss of energy equal to 0. But what does this indicate? This indicates that if your loss of energy is equal to 0, this is only possible when potentials are equal. Equal potentials means there is no transfer of charges from one body to another body. So if there is no transfer of charges, of course there will be no loss of energy. If there is some loss of energy, that means there is some transfer of charges.